Okay, in previous video we have shown about the how the rivet joint can be failed. So to estimate the load carrying capacity of joint for a single riveted, so first one, that is tearing strength. So if I applying a force of F at here and the one rivet hole that is punched in the blade and the thickness of blade that is T, okay, and that is P, that is a pitch of that particular rivet joint. So what is tearing strength? Sigma T. Sigma T is given by what are the force applied divided by the area, that is P minus T into thickness T, that is the area of plate that is tearing, is equal to SYT upon FOS. So from then you can estimate your load carrying capacity in tensile, that is P minus T into T into sigma T, or sigma T is equal to SYT upon FOS. Now that is shear strength of joint. Shear strength of joint, we all know that what are the cross section area of joint, that is pi by 4 d square. So shear strength tau is equal to F upon pi by 4 d square. F tau is equal to SSY upon FOS. For single shear we are using only one area. For double shear we are using an area multiplied by 2. For crushing strength we are always looking from the projected area. So it is, suppose my rivet and diameter is D. It is joined in two plate thickness of T, that is T plus T is equal to 2T. So the projected area is 2T into D, but we are not using the projected area 2T into D because the plate can crush at a time only in one plate. It means it can fail in only the one plate. The failure in the both plate at simultaneously does not happen. So the crushing strength is given by Fc upon T into D, that is force upon projected area. So the crushing force, that is T into D SYC upon FOS, that SYC is equal to its strength in compression. So here I am giving the comparison of single riveted and double riveted. For single riveted, tensile strength, that is P minus D into T into SYT upon FS, shear strength pi by 4 D square SY upon FS, crushing DT SYC upon FS. These two are the rivet failure, this is the plate failure. So for double riveted there is no change in the plate failure, but for shear multiply by 2, for crushing multiply by 2. Now these are the three equations that are most commonly used in the numerical. What are the efficiency of joint? So the efficiency of joint is given by, first of all, calculate all three forces and whichever the minimum load carrying capacity. We are using the minimum load carrying capacity because we are designing the riveted joint, that we are designing for lowest carrying capacity for maximum chances of safety. So minimum of FSFC divided by unriveted plate strength. Unriveted plate strength, it means suppose if you remove this riveted, so that is a plate that is P into T thickness, that is known as a P into T into what are the strength SYT upon FOS. So here is also force, here is also force. If you look at for that, you will get your efficiency of riveted joint. Now let's discuss about the numericals of this riveted joint. So basically riveted joint for numerical, I am giving you some numerical. Yes, first, if the ratio of diameter of rivet hole to the pitch of rivet is 0.5, then the tearing efficiency means you have to only consider the tearing of plate. Look at the sense, if the ratio of diameter of rivet hole D by P is equal to 0.5. They have given D by P is equal to 0.5. So here they have given the D by P is equal to 0.5. You have to find out the tearing efficiency. So we have equation tearing efficiency is equal to, in the numerator we have to use a tearing, that is P minus D into T into SYT. Here there is no vectors of T given, that's why we have taken it over. And the undivided, that is P into T into SYT will be cancelled out. TT will be cancelled out, that is P minus D upon P, 1 minus D by B, that is 0.5. So the efficiency of tearing, that will be 50%. Okay, now look at the second example. Question number 325. Yes, a single riveted lap joint, it means it is a single riveted, so we have to use the equation of single riveted lap joint of 30 mm, lap joint of 30 mm, it means diameter is 30 mm, pitch is 90 mm, and the plate thickness T is 12.5 mm. Then the ultimate strength is given, sigma T is 40, sigma shear is 30, sigma crushing is 55. What you have to find out? Tearing efficiency you have to find out, shearing efficiency you have to find out, efficiency, final efficiency you have to find out. So the numerically somehow simple that they have given the diameter of 30 mm, pitch is 90 mm, thickness is 12.5 mm. Tearing strength is given, shear strength is given, and crushing strength is also given. So what is tearing efficiency? Shearing efficiency. Tearing efficiency we have already know P minus D upon P by removing this whole the equation. What is pitch? That is 90. What is D? That is 30. 90 minus 30, that is 60. What is pitch? That is 90. You will get 66.67%. What is shear efficiency? The shear force, that is pi by D square into sigma s, and the undivided plate strength PT into sigma D, 47. Now, what is the final efficiency? You have to take out FC, FS, FT, minimum of that. So first of all, you have to find out FC, because FT and FS you have already found out from these two equations. Now, just look at the FC. That is D into T into sigma C. dt is a projected area. FC comes from this FT, P minus D into T into sigma D. Okay. So from that, you have to take a minimum of these all three. You have to find out again FS. This FS point, and for that you have to take a minimum. Your minimum will be 20625 divided by pitch 90, thickness 12.5, and again sigma T is 40, and the overall efficiency of the 4500. This is the 5 mark numerical that can be asked in the examination. Okay, now that is a particular important note on Wien formula. Whenever they don't give a diameter of rivet joint and they give a thickness. So whenever the thickness of plate is greater than or 8 mm, you have to take a standard that is the diameter of rivet, that is 6 root T. Okay. So what is the question number 6? Two plates of 7 mm thick are connected by a triple riveted lap joint, triple riveted or zigzag pattern. The permissible stresses of riveted material are shear and crushing that are given. Rivet diameter, you have to find out the rivet diameter. Okay, so to find out the rivet diameter, they will give this crushing as well as shear. So Unwin formula says this D is equal to 6 root T if your T is greater than or equal to 8 mm, but here they have given T is equal to 7 mm, so we can not use these formulas. So for triple riveted, we can put a relation that whatever my shear strength, that must be equal to my crushing strength. So triple divided, that is 3 times sigma s into pi by 4 d square and 3 times projected area into sigma c. By putting all the equation, you will get diameter is almost 17.83 is nearly equal to 18 mm. Okay, that is the question number 6. Now look at the question number 7. Two plates are joined 7 mm thick connected by triple divided zigzag. Permissible stress of rivet material in tensile and crushing they are given. So in earlier case they have given the shear and crushing. We have compared the shears and crushing forces. Here we have to compare shear and crushing forces also. Tensile and crushing, all three are given. The rivet pitch distance. You have to find out the pitch distance. So for 7 number, first of all, you have to find out what is a pitch. It is a simple numerical. Just compare the pitch and crushing, tearing and crushing, and by comparing these two, you will get your pitch is equal to 99 mm. Then compare tearing and shearing, find out the pitch. Then compare crushing and shearing, find out the pitch. Whichever the maximum pitch that we are using. But here we are getting 99 mm maximum pitch from all the joints. So these are the some related numerical with respect to riveted joints and how we can find out the efficiency of riveted joint. One thing that is known as the lozenge joint. You must know about the lozenge joint. What is a lozenge joint? Now, if you look at this joint at section AA and BB, higher chances of failure is respect to the section BB, because that is at section AA there is a large amount of unriveted joint, but at section BB there is a very low amount of unriveted joint, unriveted area. Unriveted area means the area which has no riveted joint. So lozenge joint, that is a uniform joint, and its second name that is given as a zigzag. This zigzag joint that is known as a lozenge joints. Okay, now that is not important. You can carry out by your own home. What is a basic thing is eccentrically riveted joint. So eccentrically riveted joint means a riveted joint. In earlier case we are using only tensile forces. Suppose the force is applied at some eccentricity, it means it creating a bending in the riveted. So it is a bending in riveted, it comes of the clockwise movement. Here opposite resistance that is created by anti-clockwise. This force is direct force is in downward. Resistance offered by this wall are the upward. But the second, that is the FS1, that is a primary shear force, but the secondary shear force has a direction perpendicular to the radius of the curvature. And primary shear force, that is overall force divided by 4, and secondary shear force, that is whatever the eccentricity, m into e, p into e upon summation of r square. It means you have to take the summation of this radius square into what are you have to find out, that is r1, r2, r3, r4. You can find out fs1 dash, fs2 dash, fs3 dash and fs4 dash. But by looking the figure, you have to make sure that which force will act for failure of component. It means this force will never create a failure, but these force and this force can create a failure. So we can say 1 and 4 are the critical elements. From here we can see that 1 and 4 are the critical elements. So resultant force, that is under root of fs square plus fs dash square plus 2 fs dash cos theta, and this force is equal to tau is equal to force upon pi by 4 d square. From that we can find out the diameter. And here is one numerical particular to that point. You can go through this numerical. Okay, so that is somehow about the riveted joint. These are the some numerical for practice purpose. Now for tutorial point of view, I will give you some of the numericals and that will share in the WhatsApp group. You have to prepare the tutorial book, and that will be next tutorial, that is tutorial number 7 or 8, whatever we have reached, and it is a design for riveted joint and welded joint. So riveted joint I am giving a 3 numerical that will be shared in the WhatsApp group. Okay, thank you.